everyone. Boys and girls, we're going to start a very interesting and very important topic called friction. Now let's begin our discussion by considering this situation. Suppose a heavy block is kept on a horizontal surface and you're trying to move this block. You apply some force and it doesn't move. And then you increase your force and it doesn't move. And then you yet increase your force and it still doesn't move. Then you keep on increasing your force, then at some point of time the block will start to move. Now the first thing is, if you're applying this certain force on this block and if it is not moving, that means some other force is counterbalancing the force applied by you. If we draw the FBD of this block, there is mg downward, normal reaction upward to balance mg, and this is the force applied by you. Now, in horizontal direction, if it is not moving, then the force applied by you must be balanced by some other force in just opposite direction. Now that force is called the friction force, which is acting between the surface of the ground and the lower surface of the block. It is the friction force that acts between two contacts parallel to the contact, and the force perpendicular to the contact is called normal reaction. Now in horizontal direction, it's the friction force which is opposing our force. So there is a force present. There's always a force present between two contacts which is rough, and that force is called friction force. And the second thing to note here is, when our force was small, suppose 0.1 Newton, and the friction and the block was not moving, then the friction force must also be equal to 0.1 Newton to keep the body at equilibrium. And when we increase the force, suppose to 0.5 Newton, and the block was still not moving, then friction force must also have been increased to 0.5 Newton so that the body is still in equilibrium. And when you increase the force to 1 Newton, the body is still not moving. That means friction force must have also adjusted itself to 1 Newton to keep the body at equilibrium. And at certain stage, the body starts moving, and we'll see what happens at that stage. But until the body starts to move and you keep on increasing the force, then the friction force also keeps on increasing in order to balance the force applied by you. So friction force is a self-adjusting force, and it changes its value as per the applied force by an external agency. So the first important thing about friction force is it opposes relative motion. Very important statement. It opposes relative motion. Whenever two bodies rubs each other, the friction force acts in such a way so as to oppose that rubbing. For example, in this case, you were trying to move the block in right hand side. So the body, the lower surface of this block and the upper surface of the floor would be rubbing each other. And friction always opposes rubbing between the body. So friction was acting in the opposite direction so as to stop the body from being rubbed. If it doesn't move, then the body would not be rubbing. This is the very, very important and the very basic thing about friction. And this is the concept that we'll be using over and over again when we get into a complicated system. Friction would act in such a way that it would oppose relative motion between two surfaces. Now, the only way to oppose the relative motion in this case is to act opposite to the external force so that the body does not move. That's point number one. Point number two is, friction force is self-adjusting. That means, to the extent it can, it tries to equalize itself with the external force. When the external force is zero, friction force is also zero. If you don't apply any force on this block, then as per the FBD, there's mg downward and there's normal reaction upward. There is no applied external force in horizontal direction, then friction force is zero. Friction force comes into picture only when there is some external force, because had there been any friction force, then the body would have moved in horizontal direction. So when you're not applying horizontal force, then friction force is also not there. So suppose this is the graph of applied force against the friction force. When the applied force is zero, then the friction force is also zero. When you keep on increasing the applied force, the friction force keeps on increasing. It keeps on increasing up till a certain limit. Suppose till this point the friction force keeps on increasing. Let us draw applied force on y-axis and friction force on x-axis. Now this is the stage at which the body just starts to move. This is called limiting friction. After that the body will start to move. We'll have a discussion what happens after that, but until the body moves, the friction force equalizes the applied force. And it is a self-adjusting force. It keeps on increasing as the applied force keeps on increasing. Okay? So those are two important things about friction force. The third thing about friction force is, it has been observed that the friction force is proportional to the normal reaction, to the reaction force between the contact. The higher the reaction force between the contact, the higher the normal reaction, or to say the heavier the body. The heavier the body, the higher will be the normal reaction, then more will be the friction force. More would be the limiting friction force. That means more would be the maximum friction force that can act before the body starts to move. Okay? Now, to bring this proportionality into equality, a constant will come, and that constant here we call that as mu. We represent it by mu, and we say F is equal to mu n. This is the first formula of this chapter. This is a very important formula. This formula actually relates normal reaction and friction force. This constant is called coefficient of friction.